everyone, welcome back, infrastructure admins, to this explainer. Okay, we're jumping right into an absolute masterclass today, covering exactly what you need to know for the NCP-MCI 7.5 exam. Specifically, we're tackling Objective 5.6, Virtual TPM or vTPM. Now, if you're operating with a baseline of Acropolis Operating System 7.5, Acropolis Hypervisor 11.0, and Prism Central 7.5, this is exactly the technical deep dive you're looking for. So let's get into it. Here's how we're breaking things down today. First, why vTPM matters. Second, a walkthrough on configuring Virtual TPM. Third, we'll look at external KMS key protection. Fourth, we're going to navigate some tricky exam traps and limitations. And finally, number 5, the key facts to memorize. All right, Section 1, why vTPM matters, and how it helps with securing virtual machines on AHV. So you probably already know that a traditional Trusted Platform Module, or TPM, is a dedicated microchip sitting on a motherboard, right? It provides basic security functions like securely storing encryption keys. But the Virtual Trusted Platform Module, the vTPM, well, it's a bit different. The crucial point you need to understand is that AHV VPM provides virtualization-based security, but it does it entirely in software, meaning it strictly does not require, nor does it even use, a physical hardware TPM chip on the Nutanix node to function. I really want you to mentally highlight this because exam questions love to try and trick you into thinking you need physical TPM hardware to use vTPM. You totally don't. It is 100% emulated by the hypervisor. So why even go through the trouble of emulating this hardware in the first place? Well, you're going to need to know the 4 primary use cases. First up, Microsoft Credential Guard, where the vTPM is utilized to protect Windows credentials from theft. Second, Windows 11 installation. As you might know, Windows 11 strictly requires TPM 2.0 and Secure Boot to be enabled for optimal security, and vTPM satisfies that hardware check perfectly. Third is Secure Boot for Windows, which enhances system security by making sure only trusted software loads during startup. And finally, Windows BitLocker, which uses that vTPM to securely store your volume encryption keys. Moving right along to Section 2, Walkthrough, configuring Virtual TPM, including requirements and deployment paths. Okay, before we even think about attaching a vTPM, your environment has to meet some specific software minimums. We're talking AHV version 2022-0304.242 or above, AOS version 6.5.1 or above, and Prism Central PC.2022.9 or later. But honestly, more importantly for the VM itself, UEFI firmware, that's the Unified Extensible Firmware Interface, absolutely must be enabled. vTPM inherently relies on this modern UEFI boot structure. It's simply not going to work with legacy BIOS. Oh, and if you plan to use Windows BitLocker, you also have to enable Secure Boot. These are strict prerequisites, guys. You just cannot bypass them. So let's visualize the setup. We actually have 2 paths here, and the first is the UI configuration via Prism Central. It's honestly beautifully simple. When you're creating a virtual machine under the Compute and VM section, you just navigate over to the Resources tab and follow 2 steps. Step 1, under Boot Configuration, just select the UEFI BIOS mode. Step 2, under Shield VM Security Settings, you literally just check the box that says Attach vTPM. That's it. When you're actually looking at the Prism Central UI, it's super straightforward. Notice how Secure Boot is checked right above that Attach vTPM box. This is exactly what it looks like when you're properly staging a highly secure Windows VM. Once you check that box and hit Save, the AHV hypervisor handles all the heavy lifting on the back end to provision that emulated security enclave. But hey, if you're an automation fan using the Acropolis command line interface, or a CLI, you're going to want to know the command line path. These are the exact arguments you've got to pass to provision a new vTPM VM. You use the vm.create command, but notice the specific flags here. You need machine type equals Q35, which is required for modern virtual hardware. Then UEFI equals true, Secure Boot equals true, and finally Virtual TPM equals true. Memorizing this exact command string? Yeah, that's a fantastic way to make sure you really understand the required dependencies. Now listen up, because this is a classic exam gotcha right here. You absolutely must understand the difference between creating a new VM and updating an existing one. For a new VM, like we just talked about, you just attach the vTPM during standard creation. Easy. But if you're updating an existing VM to add a vTPM, that VM must be completely powered off first. You cannot hot add a virtual TPM. No way. The hypervisor actually needs to properly inject that emulated hardware into the virtual motherboard, and that requires a fully powered off state. So once it's off, you just update the VM via Prism Central or use the vm.update command in a CLI, check the box, and power it back on. All right, let's hit section 3, external KMS key protection, and how we secure those emulated keys. So if you're using a key management server, or KMS, you have some great options for managing these vTPM keys. When you enable software data at rest encryption and configure an external KMS through Prism Central using the Key Management Interoperability Protocol, or KMIP, your vTPM keys are routed directly to that external server. That external KMS just takes over the whole shebang, the full key lifecycle, including validation and availability checks. Now, it's worth noting, if you don't use an external KMS, the keys are still protected by the cluster's native local key manager. But either way, your keys are locked down and secured. That I have to give you a critical operational warning here. Whether you're using a native or an external KMS, you absolutely must perform periodic key backups. Seriously, if your key backup file is unavailable during a disaster recovery scenario, your vTPM-enabled VMs might simply fail to start. Think of the vTPM key like a literal, physical key to a giant bank vault. If you lose a key during a move, well, you're not getting back into that vault. Always, always back up your KMS. Which brings us to section 4, exam traps and limitations. Let's avoid those common pitfalls. You really need to internalize this comparison because it trips a lot of people up. Third-party backup software running outside the Nutanix ecosystem, it doesn't have access to the vTPM data, and that includes those crucial encryption keys we were just talking about. So if you take a third-party backup of a vTPM VM, those keys are not protected. Look at the result here. If you restore a BitLocker VM from a third-party backup, it results in a completely unusable VM. We're talking unrecoverable data loss, because that decryption key is just gone forever. On the flip side, if the VM only used vTPM for secure boot, which is non-critical data, you won't lose your files, but you, or the backup software, are going to have to manually attach a brand new vTPM device during the restore process just so it can boot up. Also, you need to be extremely careful with your disaster recovery or DR topologies. vTPM VMs carry some very specific DR limitations. First off, they cannot use cross-hypervisor disaster recovery or CHDR. So if you're failing over from ESXi to AHV, the vTPM configuration migrates, sure, but the actual data inside the vTPM, it doesn't. Second, you cannot recover vTPM-enabled guest VMs at a Nutanix Cloud AZ, which is the Nutanix Disaster Recovery as a Service, or DRAS. And third, you can't enable vTPM on guest VMs that are already protected with legacy protection domain-based DR. You really have to use modern Prism Central-based replication. And finally, section 5, key facts to memorize. Time for the exam coach's final review. Okay, let's lock in these top 4 takeaways. 1. AHV VPM is a software-only emulation. Absolutely no hardware TPM chip is required or even used on the node. 2. While new VMs can have it added during creation, existing VMs must be fully powered off to attach a VPM. 3. Third-party backups are totally blind to VPM keys, which means restoring BitLocker VMs this way causes total data loss. And 4. KMS key backups are strictly mandatory for successful VM recovery. I'm going to leave you with a scenario to chew on. Knowing what you know now about third-party tools, KMS dependencies, and BitLocker keys, if your Windows BitLocker VM goes down and you only have a third-party backup without a KMS key export, how do you plan to recover that data? The harsh reality? Without proper Nutanix native planning, you literally don't. And I think that brilliantly illustrates why understanding the architecture of Virtual TPM is absolutely crucial, not just for acing that NCP-MCI 7.5 exam, but for keeping your real-world infrastructure safe. Thanks so much for joining me on this deep dive. Keep studying hard, and I'll catch you in the next explainer.